All right, to talk about the interquartile range, we need to first talk about what a quartile is. So quartiles, those are numbers that separate the data into quarters, into fourths. To find the quartile, we first start off by finding the median. So you have your set of data. First thing you do, you find the median. That's going to break up your data into two more data sets, into numbers below the median and numbers above the median. And then what we do, the quartiles are going to be the medians of each of those halves. So the lower quartile, or the first quartile, and we denote it Q1, that's the median of the lower half of the data, which is the 25th percentile. The upper quartile, otherwise known as the third quartile, or Q3, that's the median of the upper half of the data, or the 75th percentile. And if you're interested, the median is also a quartile, technically. It's Q2, the second quartile, but 2/4 is 1/2, so we usually just call it a median. All right, here is a group of 8 children have the following heights in inches. The question is, find the quartiles for the distribution of the children's heights. So first off, we want to find the median. That's going to be in the middle of the data set. So right there would be the median. I split the difference. I find the median is 53.75. Now from these 4 numbers in the below the median, so from these 4 numbers, I see that the median of those 5 is right here. This is the lower quartile, 50.5. From the upper half, that's these 4 numbers, 54, 60, 62, 71. The median of the upper half, right there, is the third quartile. So you can see each of those 3 numbers there, the median and the quartiles, break up your data into 4 pieces. Each of those pieces have 2 data points. So we have the first quarter is 48 and 48, and then we have the quartile. And then we have another 2 values, and then a median. Another 2 values, the upper quartile, and then 2 more values. All right, the interquartile range is a formula that looks a lot like the range. When you're using the median to describe the average, an appropriate measure of variation is called the interquartile range. The interquartile range, which is usually abbreviated as IQR, tells us how much space the middle 50% of your data roughly occupy. So it's kind of the range of the middle 50% of your data set. And it's given by the formula of the upper quartile minus the lower quartile. So for the problem we just did, we found the upper quartile to be 61, lower quartile to be 50.5. Well, the range is max minus min, so 71 minus 48 is 23. The interquartile range is the 61 minus 50.5, or 10.5 inches. And one more. Returning back to our first example we did with the range, let's compute the interquartile range for each data set also. And try to see how the interquartile range and range compare in terms of outliers. So for the first quartile, we find the median. Well, let's first start with the range. The range is going to be the largest minus smallest, so the range is 10, minus 1, or 9. For the interquartile range, we deal with the median, which is 10. That breaks up to 4 numbers below it and 4 numbers above it. The lower quartile, the lower half is right there. So between 10 and 10, the lower quartile is 10. The upper half, between 10 and 10, the upper quartile is also 10. So the interquartile range is 10 minus 10, or 0. And what that means is that all the numbers in the middle, 10, 10, 10, 10, 10, all these numbers have the same value, so there's no variation. For quiz 2, the range was found to be 10 minus 2, or 8. The maximum is 10, the smallest is 2, so 10 minus 2 is 8. Now, the median is 6, If I look at the bottom half of the scores, I see the lower quartile is 3.5. If I look at the top half of the scores, I see the upper quartile is 8.5. So the interquartile range is 8.5 minus 3.5, or 5. Now, in terms of which one's a better measure, you can see that, again, quiz 1, there's almost no variation. There's just one person that's different from the other 8. But it has the larger range. On the other hand, all the scores are pretty much the same, so the interquartile range proves 0. And quiz 2, again, everyone has a different score, so you can see that compared to quiz 1, interquartile range is a lot larger. That's because, like the median, interquartile range is resistant to outliers. That is, the interquartile range is robust, the range is not.